Hi class, for this module, once again, we're going to learn about polynomials. You need to know how to graph polynomials, especially the quadratic function. You need a couple of theorems so we can solve it for the solution, solving for the zeros. And of course, you need to know how to take care of the domain and the range transformation. All right, so for the first example, I want to go over the basic stuff of the graph of a parabola, which is a quadratic functions. So you see right here, the parabola open upward, so that's kind of obvious. Um, the vertex, the vertex is right here. Okay, so if they ask you for the coordinates, you just give them the x and the y. Now we need to know the intercept really well. So the intercept, the x-intercept is the point where the graph crosses the x-axis. In this case is -2. On Alex, they just put -2, but technically you have to put an order pair. So it's -2, 0, and then I have 6, 0. The y-intercept is where the graph crosses the y-axis, which is 0, -3 in this case. Now, this is important. You have to find the equation of the axis of symmetry, so they're asking you for this equation of the line right here. And you can see that the equation would be x because it's the vertical line, so is x equals 2. Now, if you just put 2, that would be nothing. So make sure you put the equation. So put x equals something for vertical, y equals something for horizontal. So make sure you put it in the form of an equation. All right, moving on to number 2 right here. So graphing the parabola, I understand that we can make the table, plot some points. For parabola, I think is if you want to use the vertex formula, you can do that. Or if you want to complete the square and rewrite into the standard form, you can do that as well. So how about I'm going to show you the vertex formula. In this case, is going to be x equals to -b over 2a. So what we have, negative b, so we have -2, negative of -2, so that's just +2. 2 times 1, so that's going to give us 1. So for y, you just plug it in, right? So y squared minus 2 times 1 plus 4. So 1 minus 2 plus 4 is 3. So the vertex is 1 and 3. So I'm going to put x here. I'm going to put y there. So here, I want you to go from the vertex. So you can see that the vertex is 1, 3. So I'm going to locate the vertex 1 and 3. So it's right here. You're going to pick the points left and right of the vertex. So I'm going to pick 0 and 2. So 0 and 2. And we should get the same y for those points. So if you plug it in, 0 squared minus 2 times 0 plus 4, it's going to give you 4, right? Now, if you put 2, 2 squared minus 2 times 2 plus 4, you should get the same number, which is 4. So we have 0, 4, 2, 4. If you want to pick one more pair, so you pick, like I said, left and right of the vertex. So it's -1 and +3. So -1 and 3. And you should get the same values for y. So -1, I plug it in. I'm going to get 1 plus 2 plus 4, which is 7. 3, I plug it in, I'm going to get 9 minus 6 plus 4, also 7. So what I have right here So we have all the 5 points. So that's good enough. So we have 0, 4, and then 1. We have 0, 4, and 2, 4. And we have negative 1, 7. So I have negative 1, 7. And then 3, also 7. And then you can graph. And that's the parabola. For number 3, I'm going to use a different method. So I'm going to complete the square instead. So how do we complete the square? First, you want to move the constant to the other side. I'm talking about number 4 here. So I subtract 4. So I have 2 x squared minus ax. Hopefully you still remember that in order for us to complete the square, I'm not allowed to have the 2 in front. So we have to get rid of it. So how do I get rid of it? I'm just going to factor it out. So x squared minus 4x. All right, now we are ready to complete the square. So remember, we take b divided by 2 square. So negative 4 divided by 2 is negative 2 square is 4. So I add 4. Now you have to be careful though. I just add 4. So technically I have to add 4 on this side right here. But I'm not just adding 4 because don't forget we have the 2 in front. So it's actually 2 times 4. So I have to add 8 on this side. Okay, so we ended up on this side is y plus 4 equals, and I'm ready to factor it out, so it's x minus 2 squared. And then I just have, because this is parabola, so I just have to move 4 back to the other side. So I have y equals to 2 x minus 2 squared minus 4. Now you can see that because I have standard form, I have the vertex. The vertex is 2 and negative 4. So 2, negative 4. Okay. All right, so let's just put 2 and negative 4 in right here. And once again, you pick left, right of the vertex. So I'm going to pick 1, 3, 0, 4. And then we just use those points and plug it in for y. So if I plug it in, I'm gonna get, so for 1, I'm just gonna do the first one for you. Negative 2. Okay. For 3, you should get the same exact number, which is negative 2. For 0, we got negative 2, 4. 4 times 2 is 8. 8 minus 4 is 4. So for 0, I should get 4. And same thing for 4, I should get 4. Now I'm ready to plot the points. So 1, negative 2, right here, 0, 4. You see the parabola is narrower. The parabola is narrower because of the 2 in front. Okay. All right. So that's 2 ways of graphing parabola. Pretty much that's 2 ways of finding the vertex. Anyway, for the x-intercept, hopefully you still remember you let y equal to 0 for the x-intercept, right? So I'm going to let y equal 0 for finding intercept. So I have 0, x squared plus 2x minus 24. And all I have to do is factor. So I have x equals to negative 6 and x equals to positive 4. Okay, so those are the x-intercept. The vertex, you can use the formula. So for the vertex, is going to be x equals to negative b over 2a. And we have standard form, so it's really easy to plug it in. So I have negative 2 over 2 times 1. So it's negative 1. And then you plug it in for y. We have negative 1 squared plus 2 times negative 1 minus 24. It's going to give you negative 25. So the vertex is negative 1, negative 25. Okay, moving on. Number 5. Okay, so number 5, they want you to write the quadratic function in the form, and I just showed you earlier this form right here. This is the general form, because based on this form, we can tell the vertex right away. The vertex is going to be HK. Okay, so we're going to do that for this one. Hopefully I have the room. So we have, first I'm going to subtract, I'm sorry, I'm going to add 47. Negative 2x squared plus 20x. And then I factor out negative 2. So I have x squared. I factor out a negative, so it's going to be a negative 10x here. Okay, I'm going to leave some room because we have to add some number. Negative 10 divided by 2, 5. 5 squared, 25. However, what I have is the negative 2 in front. So we just have negative 50. So I have to put minus 50 on this side. So what we have is g of x minus 3 equals to negative 2, and then we can just factor it out. Okay, and then I move 3 over. So now my form is g of x equals to negative 2x minus 5 squared plus 3. And you can see that we have the vertex right away, which is 5 and 3. Okay, I know it's confusing when it's come to the form right here because you see a negative. No, that's just minus h. So if you have minus 5, it's actually positive. Outside, you keep the same sign, okay? But inside the parenthesis, you change this, the sign. Okay, so same thing. We're gonna try to graph, and then we have the vertex already. So I have 5, 3 here. And once again, I'm going to go left, right, left, right. So from here. So I'm going to go for 6, 3, 7. Okay, I'm going to get those points. And you just have to plug it in, right? For 4, I'm going to get 1. 6, you should get the same number. For 3, I'm going to get negative 5. Yeah, negative 5. So we are ready to plot the point. So 4, 1. Have you noticed that our parabola opens downward? That's because we have a negative a. That's because we have a negative a here. So that's why it's open downward. Okay? So what do I have for number 6? For number 6, they asking you, so does the function has a minimum or a maximum values? First of all, you see that we have a negative number. So if it's a negative number, that means the parabola opens downward. So we have a maximum values. Okay, so the vertex go like this. So that point is going to be the max. So it's the maximum here. Okay, and they pretty much asking you where the minimum and maximum values occur. They're asking you for the vertex. Okay, so you can definitely get the vertex by, in this case, I think we should use the formula. So x is going to be negative b over 2a. So I have negative 12, negative 3 times 2. So x is going to be 2. What is a function minimums and maximum values? They're asking you for the y values. So you just have to plug it in. So f of 2, you plug it in. Okay, so when you plug it in, you solve it, you're going to get negative 1. Let's talk about the domain and the range. So you see that the vertex is right here. So for the domain, I told you before, we have to look left to right. For the range, bottom up. So you see that left to right, we go from here all the way to here. So you can see that the domain is negative infinity to positive infinity. Now the range, from the bottom, you see the arrow. So we start at negative infinity, but we stop at 1, and it's included because it's right here. Okay, so hopefully you can recognize the domain and range right away. They're asking you for the range of the quadratic equation. You pretty much just find the vertex. Based on the vertex, you can figure out the range. You see that for number 7, the vertex is 2, 1, so the range stop at 1. Okay, so I'm going to find a vertex. Negative b over 2a. So I have 24 over 2 times negative 3. Negative 4. Now I have to find y because the range is the y value, so f of negative 4. Okay, I'm going to try to solve for it. The answer is 4. So that's going to be the range. So the range is going to be, you see that, okay, you see that we have a negative number right here. So it's similar to number 7. So we're going to get the max. So we start from the bottom, which is a negative infinity, and then we stop at 4. Okay, if you have the minimum, you start at that point and then we go up to infinity. But for the max, we start at negative infinity and we stop at the max.